Well, welcome everyone. My name's Dan Wahlin, and I'm excited to be here at another ng-conf to talk to you about adding real-time collaboration into your apps using something called the Fluid framework, and that's a brand new open source project from Microsoft. So we're going to talk about what Fluid is, how you could use it, and how you can get started in this particular talk. Now, first off, in 2020, it's definitely been a rough year, I think, for all of us, so I hope you're healthy and safe and all those good things. But I think part of going through 2020 has been really upping our level of collaboration. I know I work with a team that's now distributed across the world. In fact, some people have moved to other locations because they can now. And we use Teams or maybe use Zoom or something like that to collaborate with audio and visual and chat and things like that. But when it comes down to your apps themselves, your custom apps, how are you collaborating right now? And when's the last time you actually thought about adding real-time collaboration to your app? And I'm going to offer, for most of us, we probably haven't thought about that because it's just not really something that was that easy to do. Sure, there's WebSockets for real-time communication, but real-time collaboration gets pretty tricky, and we'll talk through this. So I'm going to propose that I think over the next few years, we're going to see more of what I like to call a collaboration first design process. And this is where we start designing the app, but literally start going, hey, do we think multiple users might need to interact at exactly the same time in like this data grid, in this calendar, as they're drawing on a map with ink on a tablet or a phone? And the list goes on. Games would be another example. Are we going to build that in from the start instead of thinking about it after the fact? Because as more and more of us work in distributed locations, obviously that's going to change how we work with applications. I'm sure there's been apps you've worked on where you wish that as somebody changed something, because maybe you're on a call on like Zoom, for example, or Teams, and they changed it, and then you're like, okay, did you make the change? They're like, yeah. And then you got to refresh, or you got to wait for a timer. Now, could you do some of that with WebSockets? Absolutely, some of it. But it gets a little tricky when you start collaborating at the string level. Think of Google Docs or Word Online. That gets a lot trickier, and you have to have algorithms like total order broadcast, CRDTs, and others to actually make that even possible, because it's really tricky to merge multiple people's collaborative data into each of the clients in the proper order, in the proper time, all that stuff. So to kind of get you thinking about this, let me run off to the fluidframework.com website. You can get to the docs, API docs, all that stuff here. You can go to the GitHub repo here. But I'm going to run the playground and just run some really quick demos to get you thinking here. And the first one I'm going to run, and I'm going to show you an Angular version of this coming up, is called Brainstorm. And this allows you to add in a sticky note and then share it with others who are also connected to this current collaborative session, we'll call it. So at least one free day each week where we don't have meetings. Yeah, I'm in favor of that. All in favor? I think we would all like that. So this person sees it and goes, oh yeah, I love that idea. And they vote on it. And you can see it instantly shows up. Now, while this is in the same browser, obviously, it is using Fluid under the covers. So all the stuff I'm going to show you, it would work this way, or you could do it for real where you have multiple people in, even different countries doing this. Now, let me add another one. We need fewer motivational posters. Okay, I don't know if that's good right now. Probably we need the opposite of that, but we'll go ahead and do that. They want a gym where we can work out with personal trainers. Okay, great. And we can even type in here. I could say Dan's idea, or in this case, it looks like we have a user over here to the right, Emery. Share idea. Formal Friday. I'm not voting for that one. I don't do ties. But anyway, we can now vote. We can collaborate live. And this would be a perfect use case of real-time collaboration. It could be on agendas. It could be drawing, like I said, ink on maps or other diagrams. There's all kinds of scenarios. So could you do this with just WebSockets? I would argue you could, because at this level, we're a little higher level. We're not so concerned about order of the sticky notes. We're not allowing people to type into these at the same time. They each get their own. So really, we're just sending messages back and forth and syncing them, but that is a higher level thing you could do with Fluid. Now, you can also get really low level. If I open up this demo here and I start typing, Okay, this is more like Google Docs, Word Online, those type of things where we could have multiple collaborators. They're injecting different keystrokes, they're bolding, they're doing all kinds of stuff here. So let's bold, and this person maybe makes it italic and underlines it, who knows. This is where the algorithms I mentioned get really, really important and where they're like crucial, very critical actually, because without them, this with just WebSockets alone is super, super tricky. So this is where the Fluid framework really shines. You can go super granular down to like the string level, or you could go higher level like on Brainstorm and just send messages back and forth. Now, having shown you that, let's go ahead and now jump into, so what is Fluid then exactly? Well, we kind of just answered that, but in a nutshell, it's a collection of client-side libraries that you could use to build collaborative apps that, in essence, sync distributed data. That's what it's all about, is syncing distributed data, but it takes it up a notch. When you type and I type and Michelle types over here, we need to merge those keystrokes in the appropriate order and how they were actually done collaboratively. That functionality, I should say, is all built in. The algorithms are all used that I mentioned, and it does all that for you. In fact, it makes it where you don't even think about the merging logic on each of the clients. That just kind of happens automatically, which is really nice. Now, is this different than WebSockets? Well, it uses WebSockets under the covers, but is it different? Yeah, it is. Because when you talk about things like Socket.io, SignalR, and other WebSocket frameworks, they are all about just moving data in real time. They're real-time communication. Fluid can do that, but as I saw in like the rich text demo, it can actually go in and provide a way to move data structures around and synchronize them, merge them, and make sure everything's working as appropriate, which is really, really nice. Now, moving along here, there's a couple terms then I'm gonna throw out when we get to the code. So one of these is a distributed data structure. These are the primitive data types you're gonna use in Fluid to actually sync up a string. It's called shared string. Or a key value. That's called a shared map. Or a sequence where order matters. That's called a shared object sequence. Notice they all start with shared because we're sharing the data across multiple collaborative clients. All JavaScript clients, by the way. Now, they all send ops. An op is really just an operation. It's a change. So, they typed a character. Well, that's an op. And that gets sent up to a service, which we're going to talk about momentarily. And then what we're going to do is have a data object, which is really a type of bucket for one or more DDSs, distributed data structures, that your app actually uses. So think of this really as just a little house where the DDSs all live and they can now be used to collaborate. I don't know, maybe they have little phones, cell phones or something in the house, and they can collaborate with other DDSs that live in other houses on other clients. And that's really what's going on here. Now, to show you this visually then, we have a data object, which would be like an Angular service. So we're all used to writing Angular services with maybe HTTP client or a GraphQL client or a WebSocket client, something like that. Same thing. Data object would, in essence, be a layer of an Angular service that would have these DDSs that are used to communicate an op to a Fluid server. Now, this Fluid service that you see here, you don't write any code for that. You do have to get one running, although in the future there's going to be one provided that you could use. But for now, you have to either get one running locally, which I'm going to do in the demos, something for just local host, or using Docker containers on the GitHub repo. There's a README for this. You can actually stand up a more production quality Fluid service. And the Fluid service, though, you write zero code, though. Like nada. It's awesome. So when these ops flow up, what's going to happen is then it will relay those ops to other clients like these. They have their own copies of the DDSs and data objects. They get those. They can then synchronize the view. So I'm going to use observables actually for that in the demo. And then we're kind of off to the races. Now, the service has a little bit of storage because if somebody joins later, they need to be caught up. So it does track some things for you, but that's all part of the Fluid service layer. But the bottom line is, as an Angular developer, the only thing you worry about is really the data object and the DDSs. And the service, once it's running, if you did your own, no code's written there. It's just a reference implementation that just has to be running. And then really all it does is it stamps the ops with a number to make sure they get processed in the proper order and merged with the proper logic on the different clients. And the latency I want to add real quick here is super, super low. So latency would be, across the network. Like how long are we taking? We can't overcome the speed of light. I'm sure somebody's working on that, but haven't figured that one out yet. But assuming you're in like the same region, it would be almost instantaneous. That's how fast this is. Now, obviously, if you're across the world, it's going to be speed of light plus, a little bit of network latency. But it's very, very fast. So you could use it again for drawing, inking type scenarios. You could use it for games, tracking user cursors, multiple cursors in a doc, editing strings, all that fun stuff. So now that we've seen that, let's go ahead and move forward and we'll jump into some code here to wrap up, and I'll show you how you can get started with this. So the first demo we're going to take a look at here is a really simple one just to get us started, and it's called Dice Roller. It's kind of the hello world of Fluid, you could say. So if I open this up, it's a pretty standard Angular project, nothing special. It's created with the CLI like you would normally do, but you'll notice it has this Dice Roller data object. And inside of it, I have some packages that'll be new, such as Fluid Framework Aqueduct, Fluid Framework Map, and there's a whole bunch of others you can do as well. But this Fluid Framework Aqueduct has a really key symbol we need. It's called data object, something we talked about earlier. And you can see I'm actually creating a class, which is much like a service in Angular, where Dice Roller extends data object. Now, what that's going to do is give us some functionality. In fact, it's going to give us DDS-specific functionality that we're going to use here. So the first thing I'm going to do is come on down to the initializing first time. Now, as the comment says here, the very first client in our collaboration session to connect, they're going to call this. So just the first one, though. And what I'm going to do is go to this instance, and I'm going to get to something called the root. And this is a special type of DDS, which is the root DDS. It's called a shared directory. It can actually store other DDSs, and it can even have hierarchies of DDSs. But we're going to go ahead and set a key, and it's going to be dice value key. You'll see that right up top here. And then I'm just going to default it to 1 in this particular scenario. Now, the next thing we're going to do is once we've actually set a key and a value on this DDS, other clients are going to connect, hopefully, if it's collaborative. And so now we're going to listen for changes to the DDS, and each client wants to listen to these changes. So think of this first initializing first time lifecycle event as the first time somebody connects, this gets called. That kind of sets up the DDS. All right, that adds, in essence, a key and a value. Now, the has initialized is every other client that connects. Then they're going to call has initialized, and we're going to subscribe to any changes to that DDS. So notice we say root on value changed, and there's other types of things we can subscribe to, but in this case, value changed. We're going to make sure that the key for the change matches our dice value key up top. Of course, in this simple example, it will. And now I'm going to use a subject, and this is an RxJS subject, to actually send data off to anyone that subscribes to this. Now, you'll see that calls this .value, which just retrieves from that DDS, as you see right here. Now, the only other really useful piece here is we have this roll function, and the roll function is going to get a random number between 1 and 6, and then it's going to set that on the DDS. Now, that, of course, will call the value changed, and then we can subscribe to that. But in addition to setting it locally, it's also going to send it out to the Fluid service, and then any other clients would get it. So that's kind of the basics of how this one works as far as the data object. Now, if we go into our component here, it's kind of a single file component to keep it really simple. We're going to bind in a dice character, and then anytime it's clicked, we're going to call that roll function that you just saw. Now, the rest of this is really just retrieving that dice roller data object. You'll see this Fluid service, which is just a custom one that I use to load the data object. And it does that using container runtime factories. We're not going to get into that, but suffice it to say, this can be very flexible on where the data object is located. In this case, it's in the app itself, but you could actually load this type of functionality from like a CDN. And then we're going to subscribe to that subject that you saw. Now, I kind of skipped over the subject, but in one of my previous ng-conf talks a year or two ago, I talked about the different types of subjects. So if you're new to that, feel free to check out that previous talk. But really all we're doing is creating a subject in our data object, and then we're getting the observable. So here we're just subscribing to that observable, and then we can unsubscribe. Now, in addition to that, anytime we subscribe and the dice is rolled, the value's changed, that calls this update dice character, passes in the value of the die. We then basically get a number from that and a color. And then we notify Angular that, hey, something changed outside of Angular. And that's our change detector that calls detect changes. Now, to run this simple app, we can just go to the command prompt at the root of this folder, and we can go ahead and try this out. So I'm just going to run npm start. Normally, you'd have to run npm install first, of course, but we'll run start. Now, this is going to launch a local Fluid server called TinyLicious. Interesting name, yes. And that will allow us to try this out locally as if we had multiple people involved. All right, so there's our first person. Now let's go ahead and we'll copy and paste this. Notice this ID here. That's kind of, think of that as our collaboration document ID. So as long as someone else has that, they can also collaborate. And let's put these side by side actually. And we'll go ahead and roll, and notice every time that DDS changes, it gets relayed off to the other. That's our subscription. And then we update the UI with the dice character. Okay, so not exactly the most useful demo there because that's all it really does, but it's a good way to talk about the basics of our DDSs. So let me go ahead and stop that one. Now the next one I'm going to run is the Brainstorm because it's a little more robust and has quite a bit more to it. There's another one I'm not going to have time to run today, but this collaborative text area, if you want to check that out, that uses that shared string I've mentioned a few times. Let's go ahead and we'll close this one. We'll go off to our Brainstorm, and we'll run npm start here. All right, now this is the Brainstorm. It also has an ID here, so I'm going to copy that, go to a new tab, and we'll kind of drag this one over. All right, so now we have a true collaborative session between browsers. And as I click, we can share an idea. You'll see it instantly pops up. Same thing over here. We can vote, as I showed earlier. And this is also using DDSs, but this has 3 DDSs. It has one for the users you see up here, has one for the notes, and it has one for the votes. So we're kind of breaking this down into individual pieces. So let me just walk you through the basics of this one. It has quite a few more components in it. But when it really boils down to what it's doing, if we go into the services folder, you're going to see this Notero data object. And this does the same thing you saw earlier. It extends data object, but I'm going to walk you through real quick here some other features. So like the other one, I'm using, in this case, just a subject instead of behavior subject. But notice I've defined 3 properties. 3 shared maps. Now, what's a shared map? It's really the same thing as a JavaScript map, except instead of just adding keys and values locally, it will make sure those are distributed through the relay server that we talked about, the Fluid service, to any other connected clients, as you just saw in the demo there. Now, right now, these are just definitions. They don't do anything. We have to create them. So if we come down to the initializing first time, you're going to notice we have this create shared map for notes, votes, and users. So this is our key. And if we jump down to that, we're going to say shared map.create, and we're going to give it the runtime that's actually going to be used to send the ops out. Remember, we have operations that get sent out to the server. Well, this runtime is responsible for that. So it's kind of a behind the scenes thing that's part of our data object. And what will happen then is we're going to create a shared map for notes, a shared map for votes, and a shared map for users. And then we're going to set those on that root. Now remember, the root was a shared directory, I said. This is what we looked at in Dice Roller. And this is actually being used to store the DDSs that we're going to use. Now this whole process is only done by the very first client to connect to this. So that's kind of the only time that that'll get called. Now, as others connect, including this client, the first client, we're going to retrieve from the root the shared map for notes, the shared map for votes, and the shared map for users. Now, the reason there's two gets, this gets the handle, basically the reference that's stored up top here. And then the second get here actually gets the DDS object itself. So we're getting the reference to it, then we're getting the DDS object and pulling that out and storing it up in the property. Now, once we've done that, we have some user functionality, but then we're going to listen for any changes to what happens on these maps. And if I come on down to our create event listeners, you'll see we're also listening, just like with the dice roller, for a value changed. Anytime a value changes, we're going to grab that subject and call next, and we're just going to pass value changed in this case. Now, in the component that uses all this, when it gets that and says, okay, something changes, it'll call to the data object and get either the notes, the votes, or the users that it needs. Now, we also have some other things for users. I'm not going to go through that, but you can actually track all the users in the app. I mean, it's a collaboration app, so you kind of need that, right? And that's what this functionality is down here, but I'm going to skip over that for now. Now, the last little piece I want to show you is in this create note here. So when I hit the button to share the note in the demo I ran earlier, that's calling into here, and it just creates kind of a fake note. We get some random text from an array. But notice I'm going to call notesmap.set. So just like I said a little bit earlier, just like in a JavaScript map object, DDSs allow you to set and get data, and the underlying infrastructure for the WebSockets and distributing it and stamping the numbers and making sure everything is resolved at the right time, that's all done for us. We don't really have to worry about that. We just set and get data. That's the general flow here. Now, there's quite a bit more to this. If we go into our app component, for example, we have an app Notero component where we pass in the data object as a model property. So we have an input property here. And just like in the dice roller, I'm using a little fluid service I have to load that Notero data object, pass it in. Let's go ahead and jump to the app Notero. And this is where all the magic happens. So we have a component for the pad, which is the top part where you have the buttons and things, and you click on that initial sticky note. And then we have the board of the sticky notes. Now, really all we're doing here is just passing in that data object, which has the DDSs, and then we can act upon those. So if I come on down here, you'll notice that we're checking the model, we subscribe to changes, and that calls this changed. And then that's going to cause us to say, hey, go into the model and get the notes from the board, get the user, current user, get any other users. And then we're going to tell Angular to detect changes. So there's quite a bit going on with this one, but the actual fluid functionality is pretty straightforward. This is just functionality that's right here. And you'll notice it's just looping through the DDS, the notes map we talked about earlier, and then getting some info, creating an array, pushing it, and then returning those notes. That's actually what's being used right here. So what happens is anytime a change comes in then from a remote client, this gets called, which then kind of goes and gets the latest notes, the latest user, the latest users. And then we tell Angular to update the UI, and we kind of go from there. And then that's all just using normal input and output bindings that we're pretty used to in Angular here. Now, there's a lot more I could go into, but in the time we have, I hope that gives you at least a taste of what a data object is and how these DDSs can be used to create these collaborative sessions. And I want to kind of call out, notice that I didn't talk about a single line of server code because you don't write that code again. You just focus on the front end part of this. So that's a wrap on the demo, and I hope that gives you a general idea about how to get started. I'll have a link here at the end where you can get back to these particular demos that you see here, Brainstorm. There's another one for collaborative text area and dice roller as well. So to wrap things up, you've now seen that the Fluid Framework is an open source library. It was open sourced in September that provides real-time collaboration. So it's still a very new project. They're actively looking for feedback on bugs, feature requests, accepting PRs, all that good stuff. And they're even working on a hosted Fluid service so that you won't even have to stand up the server at all. You would just worry about your JavaScript and TypeScript code, and you'd kind of be off to the races there. Now, I've already shown you most of these links here. The main one is fluidframework.com, where you can get the docs, the playground, things like that. But the very bottom link there is where you can get to the demos that I showed earlier if you actually want to play with these on your own and get started with Fluid. So with that, thanks so much for checking out the session. I hope that, again, you stay healthy and happy and safe during the rest of 2020. We'll hope that next year we can get together in person. But I hope you have a great rest of the conference.